Okay, so here I'm going to explain how we use a photogate to measure the launch speed of our ping pong balls. So when we launch the ping pong ball passes through this black object here, and that's a photogate, and that's Miles barking, so we'll try to ignore him. So I want to explain how the photogate works. So here's the basic idea. The photogate consists of what's called an IR LED, an infrared emitter. So that is a source of infrared light that you can't quite see with your eyes. And the IR LED emits a beam of light that travels across the photogate. And it's aimed right at a detector that can sense infrared light. And that detector is connected to an Arduino. And the Arduino is running a program. And basically, what goes on is the Arduino can sense whether or not the detector is detecting a beam of light. So when the ping pong ball comes through the gate and blocks the beam, the Arduino can start a timer running. And when the ping pong ball is finished traversing the beam, the Arduino can sense that and stop the timer, and it can measure the amount of time that it took from when the ping pong ball first blocked the beam to when it stopped blocking the beam, and that gives you a time. And if you know the dimension, this dimension of the ping pong ball, if you know the time and that distance, you can calculate what the speed would be. So that's the basic idea. So mathematically, the idea is that if we know the diameter of the ping pong ball, which we call it d, and the Arduino is measuring the amount of time that the beam is blocked for, we'll call that time t block, then the launch speed of the ball can just be calculated by dividing d, the distance traveled. It takes an amount of time t block to travel that distance, so dividing d by t block gives you the launch speed. Now, there are a couple of issues, things you have to be careful of when you're making this measurement. One is, of course, the ping pong ball is a three-dimensional object, and we measure the diameter of the ping pong ball. But in order for this scheme to work, you have to make sure that the elevation of the beam matches exactly the center of the ping pong ball. So there's a lot of care taken to place the photo gate so that the location of the beam exactly coincides with the center of the ball, and that it doesn't move during the measurement. The board, if it flexes, it can move, and that'll throw things off. So that's one complication. There's another complication, and that arises from the fact it's a small complication, but it's one that we can deal with. It arises from the fact that the infrared beam actually has a finite width to it. This distance between here and here is just a couple of millimeters typically, and that introduces a little bit of a complication. And here's the idea. The way the detector works is in order for the IR detector to sense that the ball is blocking the beam, it's really wired in such a way that you have to really completely block the beam. So the place where the timer starts is right in this position here, right when the ball completely blocks the beam. And as the ball goes through, it turns out that the unblocked state will be sensed right as the bottom of the ball just begins to allow some light through. So the blocking starts at this point. The unblocking is sensed right at this point. And if you think about it, the effective diameter of the ball is really not the ball's actual diameter. It's the actual diameter of the ball minus the width of the infrared beam. So if the ball has typically a ping pong ball has a diameter of about 40 millimeters and the beam is 2 millimeters, the effective diameter of the ping pong ball is going to be 40 minus 2, or about 38 millimeters. So there's a simple procedure which I'll now explain that you can use to actually measure the effective diameter of the ping pong ball that you're going to use in calculating the launch speed. And here's how it works. Okay, so these yellow rectangles here represent strips of paper, and this is the platform of the launcher. So you take one narrow strip of paper and you tape it down to the platform, and then you take the other strip of paper and you, with a little thing of a loop of tape, you can take the ping pong ball and stick it to this strip of paper somewhere. It doesn't matter where. And then you put a little reference mark with a pen somewhere on the strip of paper. Okay? Okay, and then we're going to move the ping pong ball until it blocks the beam. And you can monitor what's going on in terms of whether the beam is blocked or not by looking at this LED that's on the Arduino. The Arduino program is written so that as soon as the beam is blocked, as soon as it detects a blocked beam, this LED lights up. So here's the idea. You take the ping pong ball, you're pulling on the strip of paper, and you're moving it until you just see the LED light up. And that will happen, as we said, right when the beam is fully blocked. Okay? So at this point, the LED has lit up, and all you want to do at this point is to put a little mark on the fixed strip of paper, marking the point at which the blocking started. And then you're going to keep going until the LED goes off. And that's going to occur right when the beam just begins to become unblocked. So, and at this point, you want to put a mark where the unblocking occurs. And then the difference, at this point you're done, except you just have to measure with a ruler the distance between these two marks on your fixed strip of paper, and that'll give you the effective diameter of the ball. And as we said, because of the fact that the unblocking occurs right when the beam starts to be visible, the effective diameter of the ball is going to be the actual diameter of the ball minus the width of the infrared beam. And that's what you should get just by going through this procedure and measuring the distance between these two marks. Right, so what we just said is the distance between these two marks, we're going to call D effective. And we just argued that D effective is equal to the actual diameter of the ball. This is D actual minus the width of the IR beam. That's this width here. And that's typically on the order of 2 millimeters. So you should find for a 40 millimeter diameter ping pong ball, the effective diameter is going to be something like 38 millimeters. And then once you have that, the way you get the launch speed, the launch, is just calculated by taking D effective and dividing it by the amount of time that the infrared beam is blocked. So T block that's what's being measured by the Arduino program. It's timing the amount of time that the beam is blocked, and you can get the launch speed. I got to spell launch properly just by dividing the effective diameter of the ball divided by this time T block. And actually, the program that's running on the Arduino will pretty much do this for you. You just have to type in what the effective diameter of your ping pong ball is into the program, and it will do this division for you and actually give you the launch speed printed out in the serial monitor.